Hi, Vanessa. Hi, Amanda.
Hello.
How are you guys?
Hello. I'm doing good.
Good. How are you?
Good.
I couldn't find some of the worksheets that you had sent out a message for.
It might be under teacher content instead of yours. Let me see if I can copy it over there.
One of them is I think it's an assignment.
Yeah, I saw that. That was the Freyer model. I saw that.
There's
Yeah.
a Freyer model assignment and the Polygon worksheet is an assignment.
Polygon worksheet.
Okay.
So, and then the other one is concave versus convex, which don't worry about it. It'll just be a Jamboard and I'll just share it with you.
Is the Polygon one, is it called Polygon Homework or the Polygon Table?
Polygon homework.
Homework? Okay.
Yeah. I'm sorry, I mean to send you that before and then I just forget. So, because it's so nice when I have you face to face because I bring them to class, right? Oh, I got to run an idea by you guys and tell me what you think of it. You're going to be like, no, don't do it for them because you didn't do it for us. Because it'll be in the fall what I was going to do. Good afternoon, everyone. How are you doing? I feel like my computer at some point is just going to explode because I have too many things open. It's going to be like, no more of this. You're killing me. It's T-shirt Tuesday too. So if anybody has a T-shirt they want to share while we're waiting for everyone, let me know. All right. All right. Does anyone have a shirt they want to share? And my internet has been awful today, just so you know. I got kicked out of my meeting twice. Yeah.
I have to be connected to my Ethernet in order to get internet.
Okay. And I am right now, Bethel, and I still got kicked off.
Oh my God.
Yeah, you're welcome. It's lovely today. I don't know what's happening. Maybe it's
Actually,
rain. Go ahead.
quick question. So the frame model, and
Yeah.
then is this the polygon and not polygon one?
No, but that's fine. Don't worry about it. I'll show you. You need that one anyway.
Okay.
Not necessarily for today, but there's one. I'll have to find. I have it in our OneNote, but I'll show you. I know I called too many things polygon something. We're like, wait a minute, what is that one?
Yeah,
Right.
I was looking and I don't know, I couldn't find the concave or not clay.
Yeah, concave or convex. That's okay because it's just a Jamboard, so I'll share it that way.
Okay then. Okay.
So, the other thing that brings up a great point, since I you know, I have to be online, live online in the fall still, which irritates me to no end, but what can I do about it? Nothing. So tell me if this would have been a better scenario for you, or if it doesn't matter. So what if, like, a week before class started or right before class started, you got a package in the mail, and the package in the mail had all the handouts that we were going to put in our notebook for the whole semester? Would you have appreciated that? And then you would just have this whole packet and you would just pull it out, you know, the ones. Yeah. Okay. Good. That's what I thought. I asked for it this semester and they told me no. And now that they told me no again and I was irritated, I'm going to cause a lot of trouble and say it has to happen, because I don't care what if I have to go copy them all myself and mail them to all my students at my expense, I will, because it's just too hard. Right. And then if people want to have them electronically too, that's totally fine. And maybe every once in a while, I would have one extra piece that I didn't plan on, right, that we would need, but not every day for sure. So, okay.
Yeah, that would be helpful because I know for me in the beginning of the semester, I didn't have a printer nor like a tablet, and my computer is not like one of those, it's just a regular computer. So to do assignments, I had to like write down the problems by hand.
Yeah. So it would be much nicer. We all agree. Okay, good. And then people who do have access to electronic could still do it electronic, right? They wouldn't have to worry about it. Like, that would be totally fine. Okay, good. So does anybody have a shirt they want to share?
I do.
I'm ready, Amanda.
So I have this Comic-Con shirt from 2016 San Diego Comic-Con when I went. It was the 40th anniversary or something like that.
Was it amazing?
It was so much fun. I was there for 3 days or something like that. It was great. I loved it.
Yeah, I've heard my kids, we haven't been to San Diego, you know, the real Comic-Con. We just went to the one that was in Phoenix before when it was here, and it was good. But I know the one in San Diego would be so much better.
It's completely different.
Yeah, yeah, I can imagine. Thanks for sharing that. Anyone else have one to share? No. Okay, mine's not mathy this time, but it's closely related and it's new. So do you like the Muppets? Yeah, Beaker was my favorite. I loved Beaker. And the other reason I feel like it was acceptable is because I taught science too, right? Math and science go together. So very handy. Speaking of which, if you teach middle school, a lot of times you specialize, right, in just one subject or maybe two subjects. So I was at a school where I taught both math and science. Sometimes you only have to teach math or science, but I was in a very particular type of school where we, our students only moved between like 3 teachers in the day. So each teacher basically taught 2 subjects, you know, and then they went out to other ones. So yeah, essay, don't worry about it. We'll see how my connection does too, because I got kicked out of my meeting twice last class. So hooray, technology, super fun. I think it was those 5 raindrops that fell that affected us, right? Yeah, that's what I think it was. Okay, so anyone else shirt to share? No? Okay, and I know some of you don't know which handouts we need or don't need. It's okay, I got you. No worries, you'll be fine. All right, so I do have a little bit of a warm up for us to review some of the stuff we did yesterday. And depending on how today goes, you will probably have a new slideshow that you haven't seen yet for tomorrow. I already have it prepped, but I didn't know how long it would take us to get through some of this, just so you know. So here we go. Remember, these were our definitions of an angle, right? So we had a turn or a rotation. That was what helped us with that 540 degrees, okay? We had the intersection of 2 rays at a common vertex and the space between 2 rays. So what I want you to do right now is I have an example for you And you can just do this on scratch paper, right? It doesn't have to be something fancy. So I want you to make sure you name these accurately. So the first one is line TS or ST, or you could use like shorthand notation with TS or ST with a line over the top, right? Oh, Karina, don't worry about it. It's okay. You can just write on paper. We'll be fine. No worries. Yeah, I hate printers too. That's the other thing I hate. I'm still on the hunt. You know, my daughter's graduating from high school this year, and I need to buy her a computer for the fall. And she'd really like a MacBook and an iPad and an Apple Pencil, which who would not, right? Are we made of money? What's happening right now? So I'm debating, do I get her some of those little bits at a time, or do I just get her like a Microsoft Surface? Anyone have an opinion, please shoot it to me in the chat or say it out loud. Either way, I love to know because you guys are, you know, like in the heat of school. So I know, Sunita, it is a good investment. I should probably just do it. Yeah. Very expensive. The problem is, Brianna, I don't think she'll get away with just the iPad and the Apple Pencil. I think she'll need a laptop too. Yeah.
If you have all three, like you're good because you can connect your iPad to your computer. You can airdrop everything from your iPad to your computer laptop. You can print off of it, and then it also connects to your phone, so you can connect all three of them together and just like airdrop documents. And then I have mine set up to my printer, so I can print off of my iPad, my laptop, or my phone. So much easier to work with if you have all Apple products.
Yeah. Yeah.
I found it easier.
Some people would say if you just buy a Microsoft Surface, you don't need any of those, right? The Surface will do it all. Does anyone have a Surface? No. I
My
have some
friend
friends who have.
does.
Yeah.
And the thing is, because I take notes during class sometimes, she can't because she's in class on it. So it's nice to have the separate.
That's true. That's facts. Thanks, Amanda. Oh, Hannah, I'm so happy you said that. So yeah, I feel like I'm just going to have to bite the bullet. Maybe I'll make her pay for part of it, right? Like maybe she can buy some of it and I'll buy the other part. But yeah, it is very nice to have it all. I agree. Okay, well, thanks for that input. By the way, are you doing this warm up yet? I'll be quiet and let you do it for about another minute. Okay, when you're done, type in the chat Mac or Windows. Tell me your preference. All right, so I know you might not be totally finished, but hopefully you're getting close. It seems like Mac is winning the contest right now between Mac versus Windows. I was a Windows person for a long time, and the reason was it's so much cheaper, right? So, but then work gave me a MacBook and an iPad and an Apple Pencil, and I'm converted. But I think it's because I didn't have to pay for it. Right? So if you didn't have to pay for it, which one would you pick? Maybe everybody would choose a Mac. I don't know. Maybe some people still like Windows. I don't know. All right. So let's look at these answers. Compare your answers with what you see on the screen and tell me if you have any questions about yours doesn't look like that, or could you write it a different way? All right, any questions? Did anyone get them all correct? So they got 5 out of 5? Nice, a couple of you. Some of you don't want to respond to me. Maybe you're still checking. I don't know what's happening. So the ones that I usually see students make mistakes on are the rays, right? The rays, sometimes I see students make mistakes on. So 2 and 3. They don't realize that they have to be in a particular order, right? Because you can't write ray YX or ray RQ because the end point has to be specific. So any questions on this? Are you all right? You're like, put this on the test. I can do this, right? Okay, so this is on your final. There's like one question with like maybe 4 or 5 images, and it's drop down matching on your Canvas portion of your final. Okay. So that might help. That's just good to know, right? While we're going over it. Okay, do you remember these? Straight angle we talked about yesterday, but we didn't talk about supplementary, complementary, or vertical angles. Anyone remember any of those? All right, a few of you do. And you could take out your amazing handy dandy angle finder and you could write those on the back if you wanted to. Some of you are like, I lost it already between yesterday and today. I hope you did not lose it. So who remembers any of these? Which one can you define for me? Can you define supplementary or complementary or both? Or can you define vertical angles? We already really know what a straight angle is. Did that turn upside down for you? Sorry about that. Okay, what do we got? It's so quiet today. What's happening? Are you guys alive? Oh my, you might not be. Okay. Oh, thank goodness people are typing in the chat. I was a little terrified for a minute there. Okay, and I know with technology, sometimes typing in the chat is easier than talking because your mic gets all crazy. Supplementary angles are 2 angles whose sum is 180 degrees. Complementary angles are 2 angles whose sum is 90 degrees. So very nice, Amanda. Thanks for putting that definition in there. A straight angle is 180 degrees. So yes, so supplementary angles, 2 angles that sum to 180 degrees. And then complementary are 2 angles that sum to 90 degrees. So I just wrote them on my angle finder like that. And then vertical angles I didn't put yet. And I could draw, if I was not in a crazy hurry, I could have drawn them very nicely and made a little picture that looks really pretty. Like I could draw supplementary angles. So I could say maybe this angle is 60 degrees and maybe this angle is 120 degrees. And then I could draw my, maybe this is 40 degrees and this one's 50 degrees. So I could make it look a little bit nicer, right? And put my drawings on there. Okay. Some people have trouble remembering which one is supplementary and which one is complementary. They can't remember. They know one of them sums to 90 degrees and one of them sums to 180 degrees, but they can't remember the difference. Does that happen to any one of you? Is there a way that anyone knows how to remember it? Like, have you had a teacher explain it to you before?
No way. I always said S comes farther in the alphabet than C does, so I know it was greater.
Nice. That's what I've heard before too from students. So, you know, C comes before S in the alphabet. So C would be the lower number of 90. S would be the higher number of 180. Anyone else have a way to remember it?
Yeah, mine was an S can be made with two C's, so a C is just 90 degrees.
Oh, nice. So an S is two C's put together. So two 90-degree angles would be 180 degrees. That's a nice one. I always ask because I don't have any great one to remember it. So I don't have a good saying or anything for that. So vertical angles. Does anybody know what vertical angles are? Vertical angles are formed when two lines intersect. Sorry, I'm weak right now and I can't take the marker lid off for some reason. Okay, so if I have two lines that intersect, no matter how they intersect, there are four angles formed, right? You can see those four angles that are formed. And I could label those angles like 1, 2, 3, and 4. And vertical angles are angles that are across from each other. So for example, angle 2 and angle 4 are vertical angles. Just like 1 and 3 are vertical angles. It's the ones that are across from each other. Okay. As opposed to adjacent angles, adjacent means next to, right? So adjacent angles would be like 1 and 2 would be adjacent angles, or 2 and 3 would be adjacent angles, right? So that's what vertical angles are. So now that you know what they are, or you're still writing them down a little bit, there's some definitions. An important thing to remember about supplementary angles and complementary angles, do you notice that I put in parentheses there that they don't have to be right next to each other to be considered supplementary or complementary? Okay, as long as their sum is 90 degrees for complementary and 180 degrees for supplementary, they are still considered that, even if they're not right next to each other, okay? So there's my definitions there. So look at this now. Can you identify which letter is a straight angle, which is a supplementary angle, which is complementary, and which is vertical? So think about those. I know some of you are still writing. I'm going to be quiet. I seem to be going fast, even though I know you're writing everything down. Sorry, I'll give you a minute to catch up. Okay, did I give you enough recovery time? You okay? Feeling good? I got a lot of cameras off, which is fine. I get it. You told me you had tech issues, but make sure you're typing to me in the chat if you need me to slow down or speed up. Okay, just so I know what's happening. Okay, because it's hard for me to gauge. Okay, so random fun time. Which one is showing a straight angle in this picture? Michaela, which one is showing a straight angle?
C.
C, very nice. Excellent. Oh, good. Everybody just wants to put their answer in the chat. Let's do that. Let's just all put our answer in the chat. Okay, so don't hit enter yet. Because listen to my question. Listen carefully. Which one is showing vertical angles? Which is showing vertical angles? Get your answer ready. 3, 2, 1, go. Oh, yeah, this is a much better game. I like this game better. Thank you. Yeah, D is showing us vertical angles. All right. How about complementary angles? Get it ready. Don't hit enter. Complementary angles. No, I'm just making you wait for me. Okay, 3, 2, 1, go. Nice. You're like, put these on the test, man. I can do these, right? Okay, and last, I'm not even going to ask you because I'm pretty sure we know this is supplementary, right? By process of elimination. By the way, I used to have a test that we took face-to-face before I switched to just midterms and finals that was matching, but there was more than one correct answer. Have you ever had those? Do you love them or hate them? Yeah, thanks. Yeah, my students never did like them, but they require a lot more thinking, right? Because there's no process of elimination there. So think about that when you're formulating your tests. I know you guys take an assessment class too, right? And they probably talk about those kind of things as well, how to formulate assessments. So think about that. Okay. Think about this and phrase how you would word it. So it says, how does the measure of a straight angle relate to the measure of two supplementary angles? So think of that. And then, can a pair of acute angles be supplementary? Why or why not? So think about those two questions. And then we'll talk about them in just a minute. All right, so let's just talk about the first one. How does the measure of a straight angle relate to the measure of two supplementary angles? Anyone just tell me what they think about it.
I'll go. I think that when I first saw this, I was thinking that two supplementary angles are what make up a straight angle because it adds up to 180 degrees. So I was thinking they're kind of like the, I don't know, ingredients to make a straight line. That's what I thought of.
Nice. Do you guys agree with Maddie? Yeah. Nice, because supplementary angles sum to 180 degrees, and that 180 degrees is a straight angle. So excellent. How about this second question? Can a pair of acute angles be supplementary? Why or why not? I see some of this going on. Tell me why not. Oh, Betty sent a great message. Let's see. Betty said, a pair of acute angles cannot be supplementary because at most an acute angle can be 89 degrees, and 89 plus 89 is 178, and that won't be 180. Very nice. All right. And McKenna has a great one too. Supplementary is angle A plus angle B, which is a straight angle. That was her answer to the first part. And then a pair of two acute angles cannot be supplementary because it would be smaller than 180 degrees. Good. So do you see how you need to formulate some answers to some of these questions and use the correct vocabulary? That's the part that gets a little tricky. Okay. Look at this picture. Tell me all the angle relationships you can think of. Okay. Don't say them out loud yet. Just think of all the angle relationships you can think of. All right. Now I get to call on people and you just tell me one of them. If you want to type it in the chat, that's totally fine. If you're the person I call on, it doesn't bother me. Okay, so Brianna, what's one angle relationship that you see in this picture? Brianna was typing in the chat before, so I'm not sure. She still needs to type in the chat. Okay, Sarah, can you tell me one angle relationship that you see in this picture? Uh-oh, our videos are off, which means we should still be here, but when I call on you and you're not answering, I get worried. Tyler?
Hi, I'm here. I just got home. Sorry, I haven't been able to look at this.
Oh, okay. All right. Hannah.
Angle B and angle A are supplementary.
Angle A and angle B are supplementary. Do you agree? Everybody? Yeah, because A and B together would form this straight angle. Excellent. Thanks, Karina. All right, another angle relationship, Elena.
Angle A and angle C are complementary.
Angle A and angle C are complementary, do you think? You guys agree? Do they sum to 90 degrees? That's what complementary would be. I'm not sure if they do. I mean, I can't tell. Maybe they do, but without the measurements, I'm not sure I can tell. Angle A and angle C do have a relationship. What is their relationship? Very nice. McKenna and Betty said they're vertical angles. Now, Elena, there is a word that starts with a C that would say the relationship between them as well, but it's not complementary. Does anyone know what that word would be? That's A and C. Essay put it in there for you. Congruent. They're congruent because they would have the same measure. Now, if I knew they were both 45, like if it said this on here, then I would be able to make the statement that you made, Elena, where you said they were complementary. Does that make sense? Excellent. Good. Now, the one thing that students get annoyed with in geometry, well, one of the things students get annoyed with, not the one, is that the drawing doesn't look like something, or they, like the drawing says it's 60 degrees, but it's not a 60-degree angle. Math teachers always say you have to go by what is written, like on the figure. If it's written on the figure, then you can assume that regardless of if it's drawn to scale or not. So that's one frustration that students share. Okay. Brianna was answering, she was having trouble technology-wise. A and B are supplementary, very nice. Okay, so let's move on. These are some of the angle relationships that I listed, which are vertical angles, which are supplementary, which are congruent. And then I just talked about adjacent angles as well. Okay, so you can review this. A lot of you had these, right? Okay. Polygons, we start talking about polygons very, very young, right? In kindergarten, probably some of you are in preschools, right, too? And they talk about shapes in preschools as well, right? So polygons in kindergarten, children describe objects in their environment using the names of shapes. So remember when we looked at the standards that one day, and in kindergarten, they could name a square, a circle, a rectangle, a parallelogram. I think it was a hexagon. Remember, they could name all those things. We were like, wow, that's pretty good. In first grade, they begin to draw them, okay, and really discuss the defining attributes. In second grade, they go further and they go more specific, pentagons and hexagons. So now it's time for your Freyer model, okay? Now it's time for your Freyer model. You should have a blank Freyer model, and hopefully you have this picture. It's probably in an assignment. Do you have this picture in an assignment? And I can put it in the chat if you need it. Let me find it. Freyer model polygons is the name of the assignment. And it's these little things are called cutouts, and I'll put it in there. Does anybody need the Freyer model there? You could just draw it on your paper. You don't have to print to this, right? Like, I get it. I don't want to spend any more money on toner than I have to. And this has 2 on each page, just so you know, you don't have to use all of them. You'll see it's just duplicated. So here are the pictures. So even if you just draw these, it's totally fine. What I want you to do is I want you to fill in your Freyer model. You can tell now you have examples of polygons and non-examples of polygons. But what I want you to do is see if you can come up with the definition of polygons and the characteristics, okay? The definitions and the characteristics. And then try to draw 2 more at least of each, a polygon, an example, and a non-example, okay? So try to fill in your Freyer model, come up with your definition and your characteristics, and then draw 2 of each. Ken, I'm going to put you in breakout rooms so you can chat about it. hello. Here comes everyone. Welcome back. Oh, my dogs want to say hi to you as well, apparently. So that's very nice of them to chime in. So how'd you do with your definition of polygons? How did you do? Someone tell me what you wrote.
So for our definition, we put a shape that has at least 3 straight lines closed.
Right. Shape with 3 straight lines, at least 3, and it's closed. I like that. Good. What else can you add? Anyone?
We said that the meaning of poly means many, and then gon means angle. So the meaning is many angles. And it's also, there's planes with straight sides in a polygon.
What do you mean, planes with straight sides?
I think, well, that was a definition that we found online.
Oh.
I think maybe it's wrong, I guess. I think that was just trying to say like each side should be equal, I think, for each other.
How I interpreted plane with straight sides is that each side of the shape, one needs to create a plane, so it has to be a closed shape, but also all sides need to be shaped. So this little like whistle shape in the knot polygon, because it has a round side, even though a few are straight, it's still not a polygon because it's round.
Ah, so part of your definition must be that the sides must be straight. Yeah. So you could say that as line segments if you want, right? You could say straight sides, whatever. Hannah put in the chat a 2-dimensional shape with at least 3 straight sides that connect. How many of you wrote 2-dimensional somewhere on your Frayer, whether it was in characteristics or in your definition? Nice. What does 2-dimensional mean? What does that mean?
Isn't that word exists only on one plane?
Yeah, exactly. But we still have a length and a width to it, right? It's not just a linear measure, right? It now has 2 dimensions to it. Very nice. All right. I like that you said closed. Did anyone write anything using those non-examples, like maybe those characteristics? Like when I look at this picture, like over here, I'm like, oh, something's wrong with this.
Yeah, I wrote they don't cross each other.
Yeah, they don't cross each other. And mathematically, sometimes people use the word simple. Mathematicians use the word simple. And so it's simple and it's closed. And simple means when I draw it, I start and finish. I can only start and finish at the same place. And I have to make an inside and an outside. Now that's not a polygon, but it is simple, right? So that's simple. Ignore the line underneath it. That's not part of my drawing, right? Okay, and then I think we got 2-dimensional because those are not 2-dimensional, right? So that was nice. Sometimes it's easier to write your definition off your non-examples than your examples. Did you notice that when you were doing it? Yeah, it's an interesting thing to do. Now, who drew some extra ones? Like as your example or your non-example? Did anyone draw anything? Jessica, what'd you draw in which category?
I drew a heart for the non-example.
Nice. And that's a non-example because it has curved sides, right? It is simple and it is closed, but it has those curved sides, which makes it not a polygon. Excellent. Anyone else draw anything? And you can hold it up if you want. All right, nobody wants to share, that's okay. So here's my Frayer model. And note I have on there that it says, instead of telling children geometric definitions, they will remember better if they come up with them on their own based on examples and non-examples. So if you just provide this to them, they will come up with their definitions. They will not Google it like some people do. I'm just saying, right? You'll remember your own definition better than Google's definition, right? Did you ever copy down definitions from your teacher and not really understand anything that you were writing down? Yeah. Why'd you write them down? Because you thought that meant you were studying, because it doesn't, right? So we pretend to do a lot of things, and teachers think, oh, my student takes notes the whole time. They must be learning. That's not true, right? If they're just copying, that's not learning. So be careful with that. So that assignment you can just upload right after class. Just make sure you have it done. Here's one of the other ones. You can sketch some of these. This is another assignment where you put these in a chart. But let's talk about regular polygons. What do you think regular polygons have? Any ideas on if
Equal length sides and the same like angles on the inside? Like
Perfect.
Measured.
Perfect. So they have equal sides and equal angles. So they're the ones that I always think when it says regular, it's like the perfect one. The one that you put inside your like Word document, right? When you do insert a shape, right? Or your Google Doc, it always puts the perfect one in there, right? That's what regular means. So it means they have congruent sides and equal angles. So regular means equilateral and equal angular, sorry. So you can tell, right? If I look at this one on the left, by the way, what shape is that, the one on the left? Yeah, it's a hexagon. So it's a regular hexagon. Look at the one on the right. What shape is that? Vanessa's like, I got nothing. It's ugly. I don't know what it is. What do you guys think it is on the right there? Yeah, it's still a hexagon. How do I know it's a hexagon? Because hexagons have 1, 2, 3, 4, 5, 6 sides. But none of you recognized it as a hexagon, right? Well, maybe some of you did. But you know, we weren't real excited to call it a hexagon because when we show kids hexagons, we often, or shapes in general, polygons in general, we often show them regular ones, the perfect ones, yeah? We need to show them different kinds so they understand that the definition of a hexagon is a 6-sided polygon, right? And polygon infers that it's simple and closed and two-dimensional, all the things we just talked about a polygon. But the hexagon just means 6-sided. It doesn't mean it has to look like this, okay? So do you see how sometimes we're teaching students things that we don't realize we are by not showing them other things? Yeah, so be careful with that. So regular versus irregular. So look at these. Which one? These are the same pictures, right, as on our polygons. So these are all polygons. Are they regular or irregular, do you think? Just look through them, pick which ones you think are regular and which ones are irregular. Okay, you ready? Okay, so let's start with this guy right here. We'll start with this one. Regular or irregular?
Irregular.
Yeah, irregular. Just because it doesn't look right, right? You're like, okay, all the sides are not the same. All the angles are not the same. So which other ones are irregular? Somebody tell me which other ones are irregular.
In the middle, in the top row?
This one?
Yeah.
Yeah, that one's irregular. What else? Oh, somebody put the kite one. So that one's irregular. And the arrow, that one's irregular. Are the other ones all regular? Yeah, so we could call this a regular hexagon. We could call this an irregular. How many sides does this one have? 5. So what's a 5-sided polygon called? Very nice. So an irregular pentagon. This is, oh, I shouldn't circle it because I circled all the irregular ones. This is a regular triangle. Do we usually call them regular triangles? Do they have another name? What's the other name? Anyone know?
Isn't it equilateral?
It is an equilateral triangle. So we could call it a regular triangle, but it really does have a special name that's equilateral. How about this? What is, oh, I really want to circle that. What is this last shape? What would I call it?
Is that a quadrilateral?
It is a quadrilateral, and it would be a regular quadrilateral. Quadrilateral just means 4-sided polygon. What do we call regular quadrilateral? Don't overthink it. Somebody knows it. Thank you. It's a square. You're like, I'm nervous to say it. No, it really is. It's a square. It's okay. It's a square. All right. All right. So there we are, regular versus irregular. How about this one? Get it ready in the chat. Is this regular or irregular, and how do you know? Everybody got it? You need 15 more seconds. All right, 3, 2, 1, go. This one's a tricky one, isn't it? We have some people saying regular. We have some people saying irregular. Yeah. Some of you are like, oh, now I just read someone else's and they're right and mine's wrong, right? You're so irritated. Okay, don't get tricked if I put it on the test, right? Okay, so remember, regular meant it has to have all sides equal and all angles equal. So this one has all sides equal, but not all angles equal. Tricky? Yeah, tricky. It's tricky. Okay, last vocabulary for today. Concave versus convex. Those words sound familiar. They almost sound kind of sciencey, like my shirt, right? So who knows what convex and concave would mean? Any idea?
Well, for number 2, when I think concave, I either think like something that is dented, or a cave itself, it goes inwards. So if concave is inwards, then convex must mean outwards, right?
What do you guys think? You think Elena's logic seems to hold true? If concave points in, then convex must point out. Yeah, that's true. And a lot of people use that definition. If you look up a definition like on Google of concave versus convex, the convex definition can sometimes be very challenging if it's written poorly. It'll say something like this: when you go from any vertex of the polygon to any other vertex of the polygon, If you stay fully contained in the polygon, then it's a convex polygon. If you go outside the polygon, then it's a concave polygon. And Madison just looked like, what is she talking about right now? Like that made no sense. Yeah, I hate that definition. So sometimes your textbook has a terrible definition. Here's a definition that's better. A convex polygon has no angles pointing inward. More precisely, no internal angle can be more than 180 degrees. If you have an internal angle greater than 180 degrees, it's concave. So if you look right here, this internal angle right here is greater than 180 degrees. Now that other definition that I was talking about, when you go from any vertex to any other vertex, if you stay inside the shape, it's convex. So for example, if I go to any of these vertexes, I'm staying inside the shape. That's what they were trying to tell you when they said that. If I go from this vertex to this vertex, do you see how I'm outside of the shape? That's what they were trying to say with that awful definition, just so you know, okay? But if you use the angle definition, it might be more helpful. Okay. I have this on a Jamboard for you. And then the only other activity I have for you for today is the polygon worksheet. Let me show you what it looks like. I know I have a tree diagram, but just ignore that. Where is my polygon worksheet? I swear, oh, there we go. Polygon homework. So on this worksheet, you're going to be specific and you're going to write like as specific as you can each polygon. So let me see. I have it right here, just so you know. I thought it was right here. Why is that so? Oh, there we go. Okay. So polygon homework? No. Well, that's stupid. There's our Freyer model. Okay, hold on. I'll put it there right now. I don't know why it wasn't there. I thought I had it there. That was probably the one you guys were looking for. It is on Canvas. I'll put it here right now. If my computer will cooperate. I don't know what I just did. Now my computer's having a panic attack. It's okay. All right, so. Oh, it is in there. I know it's in there. Here it is, right here. Never mind. This is the other assignment you can work on. So notice I put as many words as I can possibly describe it with. So I called it regular, I called it convex, and I called it a heptagon or a septagon because that's what has 7 sides. So if I was going to do this one right here, I would call this a regular, convex, hexagon. Okay, so on each one of these, be specific all the way down. Some of them you're answering other questions. Okay? Okay, I'm going to put you back in your breakout rooms. I'm going to give you the Jamboard. The Jamboard will not take you very long, I'm guessing. All you have to do is say concave or convex, okay, for each one. So do that and then work on your polygon worksheet, okay? And you can get maybe that done or close to done right now. And I'll come check on you if you need anything. Hello, welcome back. You guys, I forgot how much I love Jamboards. Yeah, I do. I don't know if you do, but I do because I can see all of you working in there and I don't have to go in a room and out of a room and in a room and out of a room. And I could have even typed messages to you on your Jamboard. So I remember we used to use Jamboards and then I got away from them. So I'm sad that I just remembered them now, but I'm glad I remembered them at all. I'm putting your exit ticket in the chat. Some of you might be like, why is she going so crazy? With like ending class right on time. I have somewhere I have to be, so sorry about that. If you guys could do a Google Meet and finish things, like if you want, you know, like that's not a bad thing. Question, Bethel, you have one?
Oh, yeah. Do you want to, are you going to see this Jamboard?
I can see it right now.
Oh, okay. So we don't have to turn it in or anything?
Nope, you don't have to do it. I've been looking at it the whole time you guys have been working. Ha, ha, ha. So very fun. So that's actually really cool. If you've never tried a Jamboard, like I can see just how you can see each other's pages, I can see all the pages at one time. So it's very cool. So try your exit ticket. Tomorrow, we're going to be starting to investigate triangles. But I do want you to think about the last two slides in here talked about what would a tree diagram look like with all these shapes on it and having irregular and regular and convex and concave. It's an interesting thing to think about. We'll talk about it tomorrow. Okay? All right, great job today. Any questions for me? All right, I'm gonna put up your final exam questions later this week and the final exam appointments too, just so you can see them and have them ready. It's not time for final exam, for crying out loud. I haven't finished grading your midterms yet, but I know that things are piling up in all your classes and you might want to balance your time. Okay, good job.